Students, this is example 11. We continue. In the previous lesson we discussed about the dielectric medium. In this lesson we discuss when we remove a dielectric, so we need to find the capacitance in both cases. So in example 11 we have a parallel plate capacitance and the dielectric medium is present between the plates. The dielectric coefficient is K is equal to 3.4. The separation between the plates is 4 millimeter, it is given, and the potential is 100 volt. So if I write the given information, so that the value of the K is 3.4, the separation between is 3 millimeter, that is equal to 3 into 10 to the power minus 3 meter, and the potential V del V is equal to 100 volts. Okay, so we need to find, for the part A we need to find the capacitance C. So simple, for part A, C is equal to K epsilon naught A over D. Because why we introduce K? Because there is a dielectric medium between the plates. So C is equal to K is 3.4, epsilon naught 8.85 into 10 to the power minus 12, and area of the plate is given, that is equal to, if I am not, area of the plate is 4 meter square, 4.0 meter square, and divided by D. Separation between the plate is 4.0 into the power minus 3 meter. So that the capacitance C is equal to 3 into 10 to the power minus 8 farad. So this is part A. In the part B, dielectric is carefully removed. So in the part B, so now we remove the dielectric medium in the as shown in the figure B. Now we remove the dielectric medium, no medium between the plates. Okay, so we again find the new value of capacitance and electric field strength and the voltage. So for part B we have to find the C new capacitance, we have to find electric field intensity E, and third one is the voltage between the plates V. Now okay, so in order to find C new capacitance, okay, so if I'm not wrong, in the A part we also have to find the electric field intensity, charge on the plate, electric field intensity, and the energy stored. So we know all these formulas. Q is equal to CV. For the A part we also solve for A bar first. Q is CV. So C is, we already found the C, 3 into the power minus 8, and the V is 100 volts, so we get 3 to the power minus 6, and but electric field intensity is V over D. So we need we have the value of V, that is 100, and D is 4 millimeter, so we get electric field intensity E. Now energy stored is half CV square, so value C is given, C is in the already found the C, and then V is 100 volts, and we take square and we get the value of potential energy. So we again apply the same formulas for B. Okay, so for the B, the new capacitance, when you have to find the new capacitance, new in electric field intensity, and the energy stored in the capacitor U, all these things. Okay, so first we find the C capacitance with the dielectric. So I say this is C new, that is C over K, because we can use directly the formula, direct formula for if the C is 3 to the power minus 8 farad with the having K as a dielectric. This is C with the dielectric medium. So we divide with the K factor, that is 3.4. This will give us this new capacitance C naught. If we say C naught or C new, that is equal to 8.8 into 10 to the power minus 9 farad. This one. Okay, for the new electric field intensity E is equal to, we need V over D. So the V is 340 volt divided by. So in the previous case the V is 100 volt, but now V is 340 volt. How it is 340 volt? Because we know that V is equal to Q over C. Increase by factor 3 over 3.4 to V, as we know that V is 340. So that the voltage V is increased by factor 4, because 3.4 factor, because we know that the in the previous lesson we discussed that the voltage increases when the dielectric medium is present between the plates. The voltage is less, but without medium the voltage is larger. Okay, after inserting the dielectric medium the voltage decreases. Okay, so here after removing dielectric medium the voltage has been increased by 3.4 times. Okay, So if 100 volt is original voltage is 100 volts, so that the after removal the voltage becomes 3.4 times the original value V. So 3.4 multiplied by 100, that gives us 340 volt. Now modified voltage is 340 volt, that divided by D, separation is the same, that is 4 into 10 power minus 3 meter. So we get 85,000 volt per meter, that can be converted into 85 kilovolt per meter. And the final thing is energy stored, that half CV square. So this is the direct equation, 8.8 into 10 to the power minus 9 farad, and capacitance is given voltage is 340 volt whole scale. That gives us the value energy stored, which is equal to 5.1 to 10 to the power minus 4 joule. Okay, I again repeat, the voltage is 340. Why the voltage is 340? Because we know that the original voltage is, starting voltage is 100 volt when the dielectric medium is present between the plates. When the dielectric medium is present between the plates, so the voltage is 100 volt between the plates. So when we remove this dielectric medium between the plates, we know that the voltage increased. Without medium, the voltage is large. We increased, voltage increase without this one. So voltage V increases, so it means, so in voltage V increases K times of V. So that's why, so if 100 multiplied by 3.4 factors, 100 multiplied by 3.4, so this will give us 340 volts. So the new potential is 340 volts. That's why we use 340 instead of 100 volt here. Okay, because in this previous lesson we already discussed the voltage V is equal to V naught over K. So here we can find, in the previous lesson we can say that V naught is equal to V multiplied by K. So that the with the vacuum, with the free space, the voltage is medium voltage multiplied by the K factor. So that's why we have to multiply with the 3.4 to get the new modified voltage. Okay, thank you.